Welcome. We might subtitle this talk, What Happens When a Computer Scientist and a Mathematician Start Talking About Teaching. So we're going to share with you a little bit of an experience of a design-based research project that we've got going on in computing, but also as it impacts calculus teaching in a flipped calculus class. So hopefully by the end, it'll make sense why we called this a tale of two calculus classes. My colleague Larissa is going to help out with the math stuff. I'll help out with the CS stuff, so we're going to tag team this a little bit today. So I'll let Larissa start talking about her context.
Okay, so how many of you are familiar with flipped classes? All right, so I'm not going to spend a ton of time talking about this here, but I teach a flipped calculus class. We've been teaching it for about 2 years at our university. Class size is approximately 25 students. The department has created a series of videos that are between 7 and 12 minutes long that our students watch as a preview for class. They are encouraged to take notes on the videos. And then when they come into class, that's where the real work happens. They take an entrance quiz using their notes if they wish. And then class time is really focused on doing and discussing mathematics. And what I found over the last year and a half or so is that by taking that direct instruction and pushing it outside of class, that I now have more time for IBL-like activities in the classroom. And so that's really changed a little bit, changed a lot of how I teach. So we discovered pretty early on that we had a pedagogical problem. When you have videos, they are often put into a learning management system like Blackboard or into something like YouTube. So this is an example of a YouTube video. It's not one of ours. And both of these contexts have a problem. The video is disconnected from the comment space. So, right? You want to comment on the video, but you've got to scroll down to get to the comment space. And the other problem is that comments aren't grouped. So if students have a question about a particular part of the video, they could be here and here in the comment space, but they're not in close proximity to each other. So it's hard for those students to see that these comments are actually related to the same mathematical idea. The other problem we have is something I call the pointing problem. Right? Think about what happens in a traditional class. You raise your hand, you say, I don't understand something, and you point at the board and say, can you explain that more? Students no longer have the ability to point at the video and say, I don't get what's going on here. And finally, the other problem I discovered is that I have a complete lack of awareness of student understanding when they're walking into the classroom. I'm expecting them to do this work outside of class to become prepared for class, but I'm not really sure what their understanding entails. And so for me, that was a problem. They walk in, and I'm not sure what they don't understand from that video. I think it's really straightforward, but then again, I'm their math teacher.
So after conversations with Larissa and some of her colleagues who were doing the flipped calculus project, we began thinking about, well, what could we do to solve this problem? So as a computer scientist, I like building educational technology. So I was sitting there thinking, well, we could build a web system that can address this. And the result of that is a system we call TRACE, or the Transformative Anchored Collaboration Environment. And what we mean by anchored collaboration is simply the pointing problem, right? We're going to anchor discussions in place and time within videos so that we maintain referential capabilities for students as they ask and answer each other's questions. So we believe fundamentally that learning and discussion are part of this activity. So YouTube is a general purpose video platform. It's meant for watching videos for entertainment purposes and lots of other things, not necessarily learning. So if we put learning at the forefront, we're going to get something that looks a bit different. So we have these spatial temporal referential capabilities, as well as the ability to categorize annotations in different ways as determined by the instructors. So they sort of set, these are the ways that discourse should work in my class because I'm teaching math, or the ways discourse should work in a history class, and that should look different. So what we'll do now is we'll take a quick demo and look at some of the major functionality of the system, just to give you a sense for how it works. So what we've got here is one of these videos from the first day of flipped calculus. You'll notice that this says average velocity and instantaneous velocity. So here we're trying to explore the difference between these two things. Now it looks like a standard video playback window, right? We've got the main video at the top, we've got a progress bar down at the bottom, a big play button, and then this thing over here, right? This thing over here is what we call the annotation panel. We'll refer to these comments, questions, things that are introduced by students as annotations generally. You'll notice that some of them are grayed out, but not all of them are. Well, the ones that are grayed out aren't relevant right now because everything is embedded at a certain time in the video. The vertical bars that you can see down in the progress bar indicate where are comments embedded in the time of the video. So if we jump forward a little bit, so if we jump forward in time to where those comments are in the video, little dots appear. That's where the students pointed when they embedded those comments. Those comments relate to what's over here that's opaque. If we click on one of those, right, it opens up, shows us what the comment is, and loads any replies that happened in that discussion. So it's very easy to maintain the what is this thing about, and then as you watch the video, these little dots just appear and disappear on the fly, showing you when there's activity or discussion taking place. If you're in the middle of the video, say here, and you say, oh, I'm wondering what this student is thinking. So we can open that concept up. The student says, well, shouldn't the velocity at the top be 0? Why is it 3 here? Well, in fact, if we wanted to reply to that, because there's essentially a misunderstanding here, right? If this is about the average velocity and the instantaneous velocity, the 3, if you look at the units, right, that's height, not actually velocity. So we could come in here and say, oh, I know the answer to that. So I might reply with a comment and say, check the y-axis label. And we can choose to post anonymously or not if we're not sure of our answer. So we'll post, and that's going to become available to any students in the moment when that happens. Okay? So that's the basic idea of how we ask and answer questions. Now, if you have a new top-level question, all you have to do is point and touch on your iPad or click, and then we scaffold the process of authoring annotations. So if I want to add a question, in this instance of calculus, the instructor said, well, first we want to ask the question, what is your question about? Is it about a concept, a procedure for calculating something, the relationship between two ideas, or something completely different? Right? And that helps prime the student to think about, what am I really asking about? What's really important here? So we would fill something in here, concept perhaps, click next, and then we can actually ask the question. And from that point on, this little dot's going to appear for everyone else who watches this video. Now, there's some other features in the system that we'll save for discussion later, but that should give you a sense, right? We're trying to make it clear to the student what conversation is relevant to the place in the video you're watching now. And if you're having the same question, it's really easy to see if other people have answered that question already, okay? There's a couple other pieces that we'll talk about in a bit. In particular, if I go to add a new annotation type, there are some instructor types. And these are things that are available for the instructor to add to a video, but students can't do those things. So one of these things is a forced pause. So the instructor can say, make the video pause at this place in time and pose a question to the students, right? Or put a bookmark here that we don't reply to, but it just helps us jump quickly in the video. So all of these things are essentially indexes into the video at that timestamp. So you can quickly navigate in a non-linear way through the video, okay? Everyone understand the context of the system? Big problem we're trying to solve? Fantastic, because now we're ready for an activity. So,
okay, so I said, if you're teaching a flipped class, I think the idea of the pointing problem is something that's very common. You've done a very quick overview of the system. What I want you to think about, and we should talk to a partner next to you, is think about how might you use this, and if you had this sort of system available to you, how could you conceive of using this? But I also want you to think about what would it need to be able to do and what would your goals be. So just want to have a conversation. So if you had to put something into a video so that your students could use that before they went to class, what would you want to be able to do with that sort of a system? Now we'll explain to you how we've used it, but I don't want to kind of color your interpretation of how you might use something like this with how we've been using it in the past. So take a couple minutes and talk about that. Remember, think, pair, share. You're at an IVL conference, talk to a neighbor.
So with folios, might be helpful to use that written communication in real time and use classes. I mean, but it's a different way. If they're posting on a wiki regular basis, then you get nice.
Something I would think about.
Okay, I hate to interrupt people. All right, so I was hearing some good things just wandering around the room. I heard somebody in the back talking about having students who all say if they don't understand, that would be a good thing to know. You were talking about real-time quizzes. I don't know if you heard somebody else over there.
well, one group didn't do their homework, so.
Okay, so one of the things we like to think about is if you have any interesting ideas about how to use the system, let us know, because we're trying to think about this more deeply as well. But I want to kind of get moving here so we can get through the rest of this. So
now, like any good story, we told you we were going to tell a tale. So once upon a time, imagine that you teach calculus and that you've been flipping for a while, and you're pretty good at this. You've got all your videos ready to go, and your students over and over say, but I can't ask questions in the video. I'm so confused, right? So you see this, and like many of you probably went, huzzah, eureka, maybe this will solve the problem. So let's try it, right? That's where our story begins. So we did it, right? In an intro calc class, and we've done this over 2 semesters. Same instructor, same videos. Okay, so what we're going to see here, in the fall of 2013, we had 19 students who consented to be part of our research study out of about 25 that were enrolled in the class. 23 videos were in common between the 2 semesters, so that's the data that we're looking at in this study here. First question comes up, do my students actually do what they're supposed to do? Right? Do they watch the videos I assign them to do? So good news is about 80% compliance with a student watching 80% or so of the videos that were assigned that semester. So hey, pretty good, right? Now, we're not telling you how long they spent on each video, but at least they looked at it, right? We could tell you that other thing, but that's a later story. Average number of views per student per video, or per student per semester, about 31. So at 23 videos, 31 views. They're looking at each video about 1.5 times. So some videos get watched twice, most videos get watched once. Right? That's pretty typical. So what do we think spring looks like? Well, about the same, right? So on almost all of these things, more or less the same. And if you do some t-tests, right, they're not statistically significantly different. Right, so still fairly good compliance with the instructions. They're watching the videos, and they're watching things 1 to 2 times. Right? So looks the same, right? These 2 courses, just replications of each other. Right? Well, let's go look and see how they dealt with the annotations. Were they asking questions? Remember, that was the problem. Right? Are they asking and answering questions? Right, so here we're going to see the annotation authoring behavior in terms of the number of students, total annotations in the system, and then were they created by students or instructors. So in the fall, a whopping 27 annotations. Wait a second, there were only 23 videos. So that means most videos had like 1 annotation and maybe a half a reply. That sucks, right? And annotations made by students, well, there were only 9 of those, but the instructor, well, wasn't much better, right? So the instructor didn't even post 1 annotation per video on average, right? No offense to instructors.
That's all right.
Right? So we're scratching our heads a little bit thinking, well, this behavior, right, we built this system where it solves a problem they actually had, what's going on here, right? So we've conducted some focus groups with some instructors and talked to them a little about, well, what was going on in the fall semester? How did you use the system? What were the issues that you had with it? And then we made some tweaks, and we'll save the tweaks we made for later. But in the spring, same videos, same instructor, we see 735 total annotations by 16 students, so fewer students here. 2/3 of them were authored by students, and about 1/3 were authored by the instructor. Orders of magnitude more interaction in the system. So, right, good job, right? This is more what we wanted to see. Right, so here's an illustration. Here are 2 different videos. This is that progress bar at the bottom. So at the top we see limit laws part 1, and at the bottom we see the derivative of polynomial and exponential functions, right? Is that right?
Yeah.
Fantastic. Not a mathematician. Right? So you see here 1 lonely annotation in both of those videos in the fall. What did spring look like? Right? So the qualitative difference as you watch and experience these videos is quite different in the 2 semesters because of the activity in the system. Right? If we look at, well, were they contributing top-level annotations or replies? We see that typically in the spring, students contributed mostly replies, but about 1/3 of them were or a quarter of them were our top-level replies. And the opposite is sort of true for the instructor. Right? On average, students posted 29.6 annotations over the course of the semester. Right? That's pretty good. So what was different? Any hypotheses? Did we bribe the students? That's an interesting hypothesis.
No bribery took place.
Okay. Well, I was waiting for that, right? Anything else but, oh, it was just part of the grade, so they did what they needed to do to get graded. Right? Oh, skeptics here, skeptics, right? So in these focus groups, we talked with instructors about sort of what they needed in the system and why students perhaps weren't actually engaging with the system. So we made 2 technological changes to the system to better support instruction. Right? And Larissa is going to talk about what changed in the instruction to go along with this. The first one was that we allowed the anonymous replies. In the fall semester, students had to post with their identity, right? First initial, last name was their username. So allowing students to mask their identity on a case-by-case basis if they were unsure of their question, right? They didn't want to look naive when they asked a question, particularly if that was going to become part of some digital record, right? We've heard a lot about digital privacy lately. It's on the minds of students. So obviously, we thought this might make a difference. The X's you see here is a post from a student who did not consent to be in the study. So we have to mask that out for presentation. X's did not show up in the semester. Secondly, we had these forced pauses in the fall, but you couldn't reply to them, right? And if you replied to anything, it was public to the world. But in talking with the instructors about ways they might use the system, this notion of, well, what if I used it to get some feedback from the students about what they're thinking, not biased by what other students are thinking, right? So they need to be able to have a conversation with the instructor privately in the system so I can get honest feedback, instead of them saying, oh yeah, me too, right? Whatever he said or whatever she said. Right, so we added the ability to reply to these pause moments and then to mask, if the instructor so chooses, a student's post from all the other students. So it's conversation between the instructor and the student. So Larissa will talk about what she did with this in her classroom.
So I think really the driving factor behind the changes I made was my dissatisfaction with my knowledge of student understanding when they walk into class. Is that I would ask students at the back of their entrance quizzes, did you have any questions? And they would come up with lists of them in the fall, but they wouldn't post anything in the system. So I wanted to find a way to kind of elicit student understanding of the videos while they're watching the videos. So I had some information when I walked into class and to help me guide instruction and alter instruction and change activities. So that was really the driving factor behind the changes I made. So certainly I decided that if I wanted them to put annotations into the video, I would have to value it some way. And the way students put value on things is if it's part of their grade, they'll participate in it. So again, in my class, because they work in groups, I regularly give them group quizzes because I value that group interaction. And if I value that group interaction, I need to provide them a grade for it because that way, that's how they value it. So I did that. Guiding questions for the video. I found in the fall my students, even though we describe our videos as pithy and short and kind of to the point, they still have no idea about what's really important in there. And that's not unexpected because they're novices and they think everything's important. So I gave them lists of guiding questions to use along with the video. I also gave them metacognitive prompts at the end of the video. So one of the previous examples was an example of that. I put a forced pause at the end of the video and I say, ask one question that, if answered, would help you better understand a concept or procedure, as appropriate, in this video. And then I also liberally used private reply annotations, in addition to the one at the end. I would sprinkle some private reply annotations in the middle of the video to use them like the idea of a quiz. So I'd ask them something like, what's the derivative of a function? Or I might ask them, what's the relationship between the number of rectangles and the width of a rectangle if we're doing area underneath a curve? So trying to, again, to elicit understanding of the particular concepts or procedures in the video, but also giving me information for class. And then I think the other part that I think made this successful was a deliberate integration with class. So rather than thinking of videos outside of class and classwork as being separate, how could I interweave them together? And the way I chose to interweave them is to take the students' questions and comments and replies and read them through. I read them through. They had a due date 2 hours before the end of class. I would sit down at that point, read all their annotations, and adjust my lesson plans and my activities and kind of where the class discussion was going based upon the comments in the videos. And then I'd get into class and say, hey, you know, we had some really good questions posed in these videos, and this is the way we're going to start class because these are the questions your classmates have asked about these ideas. And so I'd make it really obvious that I was using their questions in the videos to drive instruction.
So what you see here is one of our analytic tools in the system. We track lots of things in student behavior in the system. So this is just showing you every row is a student, every column is a video, and what were the number of annotations authored by that student on this video. The numerator is the number of top-level comments, and the denominator is the number of replies to other people's comments that you see here. So the heat map shows you the redder the color, the more activity for that student on that video. And really what we're trying to do is show instructors what's going on in their class so they can make some of these just-in-time modifications. And we can talk about the analytics at greater detail maybe offline. But this is the qualitative difference. We went from a matrix that had almost no color at all in the fall to something that is fairly well filled out, right? We went from very, very sparse matrix, to use a math term, to very, very dense matrix. So we're pretty happy with that. So, and they lived happily ever after, mostly, right? So the moral of this story, I suppose, is that if you try something the first time and it doesn't quite work, don't lose hope, right? We can still think about it critically and figure out, right? We think we're moving in the right direction, right, in terms of what the system can do and in terms of how we structure pedagogy around that, but we still have room to improve. A lot of the replies are done in these private spaces at the moment. We want to move more of that discussion into the public space where it becomes a thing to talk about and think with. Right, so we have some ideas for how to modify things over the summer and try out again in the fall. So the great thing about design-based research is we just keep trying over and over and over and tweak changes and see what happens. So I really do believe that evolving pedagogy with technology hand in hand is really a crucial way to move things forward. So think about that, not to say that you have to use our system or think about that, but whatever you're using, think very critically about it and how you would modify it and your own instruction. So we have lots of next steps that we're looking at. Examination of how students navigate in videos rather than just they viewed it or they didn't, but did they use nonlinear viewing techniques? Were they jumping around? Were they watching it for a certain amount of time? How do those things correlate with course performance metrics? We're crunching those numbers right now. Doing some qualitative interviews with students to see how their in and out of classroom experiences sort of come together and help them better understand calculus. And obviously we're going to keep evolving this as this project goes on. So here we are at the end of our tale, and we'd like to acknowledge our funding source at NSF, and we'll take any questions that you guys might have.
I'm Michelle Smith, and my question is, how did the grade distributions compare between the 2 semesters?
I haven't looked at the grade distributions across the 2 semesters yet. Yep. And it's hard, it requires more than just a simple comparison because my spring semester students, that's our off semester calc class. There are weaker students, our repeating students, the students who took pre-calc in the fall compared to our spring.
Yep.
Compared to our fall
Yep.
class.
And
so
in that sense,
it's not just a simple comparison.
Yeah, so in that sense, it's actually even more surprising that they interacted more.
Hi, I'm Allegra. How many other faculty members are teaching flipped at your institution?
So right now we have 4 full-time faculty. We usually run about 4 sections of flipped faculty, flipped classes taught by faculty. In the fall, all of our classes will be flipped, both taught by faculty and adjuncts. Only right now the 4 faculty who are full-time faculty are actually using the system.
Okay. Did you find there was any difference in student interest in the course because they had heard this was going on in the fall?
Hi, Perry Lee from Kutztown. Just wondering, do you plan on creating your own videos to tailor the way you teach?
Calc videos, we have calc videos. Oh. So my flipping calculus project is funded by is that NSF DUE grant, and we do have calc videos publicly available. If you Google flipping calculus University of Hartford, you should come up with it. And if you don't, email me, talk to me, corner me, I'll find it for you. Oh,